Elise, look! That's why don't you go show us what the isobaric graph looks like?
Is that the monkey bars?
Yes, sure it is. And that's how it's done.
Hey Angeline, look at that! It's an Ising volumetric graph! Why don't you show the people what that looks like?
Oh, sure.
Completely vertical.
Wow, I finally made it. That was so fun! And it looks just like an adiabatic graph.
Except, they're not real kids. Tag, you're it! Time out.
What's wrong, Luis?
This graph, this slide, it's an isothermal graph.
Whoa, you're right. Wait, what?
So this is the Unit 6 All or Nothing quiz review. So, for a 0.03 mole sample of helium is taken through the cycle shown in the diagram above. In one complete cycle, the work done is negative 500 joules. From C to A, 100 joules of energy is removed from the cylinder. Part A says, find the temperature at state A. Well, from here, you know that it's 1 atmosphere, and you need to convert this to pascals of atmosphere, or pascals of pressure. So 1 atmosphere is equal to roughly 1 times 10 to the 5th pascals. So if you have 1 atmosphere, you get 1 times 10 to the 5th pascals of pressure. Then, using the equation PV equals nRT, we can use the pressure that we now have, the volume which we have, N, which is the number of moles, and R, the gas constant, to find T, the temperature in Kelvin. So once you realize that, you just plug everything into the equation. So 1 times 10 to the 5th times 0.001 equals 0.03 moles times 8.31 times the temperature. Then the temperature is equal to 401.12 Kelvin. For part B, for each process in the cycle, fill in this chart. W is the work done on the helium sample. So first you need to realize what formulas you need, and that's work equals negative P delta V, and delta U equals Q plus W, and then just realize that delta U is dependent on the temperature. So first things first. So it's given that from C to A, from C to A, work equals negative P delta V. So you're given that the pressure is 1 times 10 to the 5th pascals, and the change in volume is given by the graph here. So it goes from 0.01 to 0.03. So when you do this, you find that the work is equal to 200 joules, and you plug it into the table there. For B to C, you know that the entire work of the whole cycle is negative 500 joules. because that is given up here. You also know what the work done from A to B is. It's 0 because the volume does not change at all, and the pressure, so delta V is 0. That means that work equals 0. And then you just found out what the work from C to A is. It's 200. So you plug that in there too. And then you can find what the work from B to C is. And then you find that it's negative 700 because the total is negative 500. Yeah. And then you just plug that back in too. So for the next part on the delta U's, you need to realize that delta U is related to the temperature. So from B to C, the change in temperature is 0. That means that delta U is also going to be 0. So that's for the total process, the total cycle. So at the bottom, you can write what the work and everything is for the total cycle. That's this bottom row right here. So write in 100 for there. And then you know that from A to B, 100 joules of energy is removed from the cylinder. So you write that in right there. And then delta U equals Q plus W. So you can use that to solve for the last delta U. Then just double check that everything adds up to the bottom rows, and that if you plug each of these values into the formulas, work equals delta P, P delta V, and delta U equals Q plus W, that you get the right answer. So, part C, is this an engine or a refrigerator, and why? Well, first of all, it's an engine because the work done on the system is negative. That means that the work done by the system must be positive. They're inverses. So, in other words, this cycle is giving energy to the system, which translates to work because it's getting negative work, which is giving. It's just a weird way of saying it. So the easy way to tell, instead of thinking about all that, is just to realize that if the arrows are clockwise, it's going to be an engine. So this is all you need to know for the Unit 6 All or Nothing quiz. Good luck. So the work cycle type stuff is what was on the review for the All or Nothing quiz, but Unit 6 is not just work cycles. It also has a lot of things to do with other fluids. So to review that, I have this problem here. We have a container filled with liquid with a density of 1.1 times 10 to the third kilogram per meters cubed. A small hole is made in at some height into the cylinder with an area of 2.5 times 10 to the negative 6 meters cubes. In 120 minutes, 7.2 times 10 to the negative 4th meters cubed of liquids flows out. And, importantly, the liquid is topped off constantly to keep the level H constant. So, the first part is asking the volume rate of liquid in meters cubed per second. So that's just the amount of volume that comes out per second. So it says that 7.2 times 10 to the negative 4th comes out in 120 minutes. So, also here are the formulas from the unit. We won't have to use all these, but these are all the ones that we could use. So, flow rate is essentially what this is asking for, is V over T. That is just 7.2 times 10 to the negative 4th over 120. And that equals 6 times 10 to the negative 6th meters cubed per second. So that's your flow rate. Easy peasy, part A. So for part B, it's asking the speed of liquid as it leaves the hole. Right there. So, flow rate. So this is a continuity problem. So we're going to use the A1 V1 equals A2 V2 combined with the AV equals VT. So AV equals VT. Yeah. Alright, so the area is 2.5 times 10 to negative 6th times V2 equals the flow rate, which is 6 times 10 to the negative 6th. And what you get is that V2 is equal to 2.4 meters per second. And that is the speed of the liquid as it leaves the hole. Pretty cool that you can figure that out. Okay, part C. Determine the height h, which is this distance right here, the water level or liquid level, above the hole that causes the speed from part B, 2.4 meters per second. So to do that, we need to realize that this is a question where we can use the Bernoulli continuity principle, which is that whole thing. So P1 plus rho GH1 plus 1/2 rho V1 squared equals the absolute pressure 2 plus rho GH2 plus 1/2 rho V2 squared. So we can cross a lot of things out because a lot of things are the same on both sides of the equation. For example, the absolute pressure P2 does not change from P1, so you can cross those out and they cancel. The density does not change in any of these. It's the same liquid, so you can cross out the row there. We can cross out the row there. And eventually we'll just be able to cancel out a lot of these things, so I'll just go ahead and do that. Yep. So eventually what we're left is with GH1 equals 1/2 V2 squared. So G is just the force of gravity, so that's pretty much 10. H1 is what we're trying to find out, equals 1/2 V2, which we found from the previous problem is 2.4. 2.4 squared. When you solve that, H is equal to 0.288 meters. Give or take a bit. So this is how to count the problems from the first part of Unit 6 before you get to all the crazy looking diagrams and stuff. Yeah, pretty simple.